Hey everybody, another contest problem where we're trying to multiply a logarithmic expression. Now it turns out to be useful to convert that logarithmic term to an exponential term. It's just easier to manipulate. Just a quick example of what I'm talking about. We know that log base 10 of 1,000 is equal to 3. And that's tantamount to saying 10 to the 3 is equal to, that's if and only if 10 cubed is equal to 1,000. And that explains that exponential representation, again, turns out to be quite convenient. And that's what we do on these two statements right here. Now notice we gave this a name. It's just easier to carry around a single letter. So we ended up calling this C. So it's clear that we're trying to maximize C. We're trying to maximize the single term C. It's just easier to carry around in the processing. So let's continue. Now we have a couple of givens also. These two, in the second sentence here, we have these couple of givens that gets transformed into these two forms based on these exponential representations. All right. And this part right here is very straightforward. This is just the multiplication property of exponents. If you have an exponential raised to an exponential, you multiply the two exponents. Down here, we just equate the two exponents since the bases are the same and the exponential function is 1 to 1. Now, we get this statement, and D is equal to 7 minus C. If you take a look right here, just remember you can see why that's true because D is equal to 2 raised to the 7 minus C, sorry. 128 is equal to 2 to the 7th power, which is exactly where this 7 comes from. And notice when you divide through by 2 to the C, you subtract the exponent. It's a well-known property of exponentials. Okay, so everything else just follows immediately from these above statements, and we end up getting a quadratic expression, which is very, very convenient here. And we get the expression in terms of C, and that kind of directed these statements. We wanted to get C by itself in a single expression to see if we could figure out when C could be as big as it could be. And so certainly right here, we can equate. Notice right here again, we multiplied the exponent. 7 minus C times C is 7C minus C squared. Okay, so we can equate the exponents again, and when you equate 7C minus C squared equals to 8, that ends up being the very same thing if you want a 2 to the 8th, excuse me. My bad. Let me erase that. Okay. Okay, we're equating the exponents, so we have to set this equal to 8. Again, folks, this is just a straightforward truth. Since the exponential function is 1 to 1, we can equate the exponents. But that results in this quadratic in C. If you get everything on one side and multiply through by minus, it's a little bit easier to process it, I think. 7 squared minus C plus 8 plus 8 is equal to 0. So folks, you could try to complete the square, but it's kind of a hassle to take half of 7. So I'm just going to use the quadratic formula, and you're going to get C is equal to negative a negative 7, which is 7, of course, plus or minus. Yeah, I'll go ahead and do this in my head here. You would have 7 squared, which is 49 minus 4 times 2. Okay, so I'm getting 17 right here, all over 2. And again, y'all, this 17 comes from 49 minus 32. I'm just writing it down myself to make sure I'm getting it right. 49 minus 4 times, there's a 1 here, right? 4 times 1 times 8, so minus 32 right there. Good. So that explains where this radicand came from. Now, what we're trying to do, we're trying to maximize C. Remember, we're trying to find the maximum value of log base 2y, which we called c. All right, and so it's very clear that the c we're interested in would be this problem was intriguing because you get the impression integers are going to be the solutions here, but it's just a real number, 7 plus root 17, and we never found out what y and x was. I guess we could from here, but that's the answer. 7 plus root 17 divided by 2 is the solution, irrational solution. And again, you got to pay attention to the fact that x and y are positive real numbers, not necessarily integers. You might anticipate integers being solutions to something like this, but indeed it's a real number solution, and there's your solution, 7 plus root 17 over 2. Thanks for viewing.